are talking about volumes of 3D figures today. It'll be prisms and pyramids and cones and spheres. We will also talk a little bit about surface area, although not a ton. Prism is a 3D shape with a polygon for a base and parallel sides. So the polygon could be anything. We typically think of it as being a square with things jutting out from it. But it could actually be even like, some non-right, non-regular shape with sides jutting out of it to form the other parts of it. Think of it as a base on top and a base on bottom with stuff connecting in between. A cylinder is a prism whose base is a circle. I'm going to show these things better with Sketchpad in a second. But a cylinder is just a prism with a circular base. A pyramid is a 3D shape that has a polygon for a base, but then the sides meet at a single point. Let me show you some examples of this. So think about this shape right here, this shape right here, like that's a square or some sort of rectangle sitting flat on the ground. It doesn't actually have to be a rectangle. It could just be some sort of a parallelogram of any sort. So it's just some quadrilateral sitting flat on the ground. Well, that right now is a two-dimensional shape. If I were to take the bottom and drag it up, I've now created a three-dimensional shape. This has volume, and this is called a prism because the top section and the bottom section are the same with these parallel sides. Finding the volume of a prism is very simple. You just find the area of the base. You find the area of this base down here, and then multiply it times its height, because that's basically what I did to create this. Like, take the area of the base, which is this, and then multiply it times its height. It's like you're stacking a whole bunch of bases on top of each other. My son just turned 3 and got a slinky for his birthday. And a slinky is a cylinder, basically, with a whole bunch of rings just stacked together and linked together. And you can keep getting them taller and taller and taller as they form. As they form. A pyramid is the same idea of having a base that's some sort of polygon or a circle. So think about this triangle here as just being the base. But in a pyramid, everything comes to one point. So if I were to drag, there we go, drag. This right now is forming a pyramid. It's not a pyramid yet. This would be like half of a pyramid right here. But once everything comes together and meets at a single point, we formed a pyramid. A pyramid doesn't have to have a triangle for a base. It can have a square for a base, the pyramids in Egypt do, but it could also just have like a pentagon or an octagon for a base. The base can be any shape, but the sides all form triangles. So this is pretty cool, I think. It's almost better to think about a pyramid as coming from the top down, which I have below. It's like here's a pyramid, but if we wanted to grow the pyramid, it's healthier to think of it as growing this way. Pyramids would grow from the top down. I learned it's actually pretty cool if you just start like, I didn't know I had really made 3D shapes, but I kind of had, and that's pretty fun. Okay, so do we understand the gist of what makes a prism and a pyramid a pyramid? And then a cone is just a pyramid with a circle for the base. Well, to find the volumes of these shapes, we just take the area of the base and multiply it times the height. Like this right here is the best way to think about finding the area of a prism, or the volume of a prism. Do the base area times the height. For a pyramid, you do that same thing, base area times height, but just times a third. The volume of a pyramid is 1/3 the volume of the cube it could fit in, or the volume of the box it could fit in, I'll say. So let's just pretend together that this right here is a square base. Okay, so this is clearly a right angle. Let's pretend like this is also a right angle, just on the floor. It's tough to show 3D perspectives. It's kind of fun, if you took a second to stop and look at which side of this do you think is sticking out? Which side is on the ground? The dotted lines are supposed to be behind the perspective, but if you sort of like let your eyes sort of just blur or look at one point for a while, you can sort of shift it around, and that's fun. So to find the volume of this prism, I would find the base area, which is 25 times 14, and then multiply that by the height, which is 30, and it's just 25 times 14 times 30, which is pretty straightforward. These are all inches, so if I do 25 times 14 times 30, it's 10,500. And because it was inches times inches times inches, that's inches cubed, not inches squared. Volume always has a cubic measurement. So that's pretty straightforward. The volume of that rectangular prism was 10,500 cubic inches. Now let's do this. We'll also say this is a rectangle, just to keep things simple. This rectangular pyramid would be the base, which is 500 times 300, times the height, which is 800, all times a third. It's a third times the base times the height, base times width times height. Base area times height is the best way to say that. Well, whatever that is. 500 times 300 times 800 times a third. Or divided by 3, same thing. Boom. 40 million? Yeah, that's 40 million cubic feet. It doesn't take much for things to get real large real fast when you're multiplying 3 things together. For the record, what these numbers mean is, like, if I took an inch and made a cube out of it, here's 1 cubic inch, I could fit 10,500 of those inside that space. Kind of nuts. Okay, the last two were called right prisms and right pyramids. Right means that they went straight up, okay? So this is a right prism because every angle, because this angle of the height is a right angle. It's shooting straight up. And we were, with this one, it doesn't really matter if it's a right pyramid or not. Just any pyramid is going to have the same volume. But this here is not going to be called a right prism. It's got a height. I'm sorry, it's got a slant. This fact that this is slanted throws off the fact that it's not a right prism. The volume doesn't actually change at all, though. The calculation is going to be the same. Again, if I could find it, I can't find that slinky I gave my son. I didn't give it, his aunt did. But imagine a slinky, you know, that's doing this. They're almost always bent at some point. But the volume of that slinky is going to be the same as the volume of the slinky if I push things off to the side and have the slinky looking like this. The volume is not going to change as I twist it around. So the volume of a right prism is the same as the volume of a non-right prism if you just take the top and slide it over. I'm going to do the same thing, though. Here's the base. Here's the height. See, the base right now isn't a rectangle. The base is a parallelogram of some sort. But here's the base length, here's the base height, and here's the overall height. Length times width times height. So it's just still 4 times 13 times 17. I'm not going to calculate that. We get the idea. For this cone, to find its volume, I have to find the area of this circular base. So the radius here is 15 centimeters. So the area of this circle is pi times r times squared. Pi times r squared. So pi r squared is going to be the area of the circle. If I do that times 15, sorry, 50, not 15, 50 pi r squared, that's going to be the volume. I'm, again, not going to take the time to calculate that. We can do that. Oh, I then have to cut that into thirds, because it's a cone. It's like a pyramid. It's a cone, not a prism. That would be the volume of that cone. Run that calculation, you got it. Okay, something I'm going to start talking about today, but won't be on your homework for today, it'll be on your next homework, is surface area. Surface area is basically asking the question, how much stuff does it take to make the outside? You could also say, if I wanted to paint the whole entirety of, like, say, this box, how much paint would I need? This shape, this prism, has 6 sides. There's this red rectangle in the back. I'm shading the back right now, okay? The red rectangle in the back. And it might look like the front now based on however your perspective is changing. There's the red rectangle in the back. the red rectangle in the front, the blue rectangle on the side, and the blue rectangle on this side, and the green rectangle on the bottom, and the green rectangle on top. There are 6 faces, but each face has a congruent pair. Left, right, top, bottom, side, side, front, back, I'll say. Left, back, left, right, top, bottom, front, back. So to find the surface area of this, it's going to involve finding, like, say we did this side first. Okay, well the area of this is 15 times 18. I'm going to call all these rectangles for now, 15 times 18. And there's 2 of those. There's 1 on each side. The area of this is 10 by 15. And there's 2 of those. And if I do the front face and the back face, so this is me, I'm going to color in the back right now. Color in the back. Color in the back. The back is 10 by 18, because this length is 10. And of course, there's 2 of those. If I add all that up, that gets me the surface area of this shape. I've got another little thing to kind of show surface area. I like making these sketchpad doodles. Here is a box map. Okay, so imagine you just got something from Amazon and it came to your house and you carefully open up the box that it comes in and you pull out all the flaps. Well, this is an open-faced box. There's no top to it, so you can't actually think of this as an Amazon shipment, but whatever. This over here is called a map, a box map of how to make a 3-dimensional shape from 2-dimensional pieces. You'll notice that, like, as I move this around, these 4 flaps, like there's a flap right here and a flap right here, these 4 flaps are going to get bigger or smaller, and that changes how the box is going to actually be able to get formed. As this shrinks down, the box gets shorter and shorter, wider and wider and wider, or it can get really tall and really thin. And over here on the right, I'm actually calculating the volume of the box. This is something that I do in pre-calculus. We find which of these shapes gets us the biggest volume. It turns out it's this one right here, where the top is at the highest point on that red graph. But if I were to find the area of all 5 of these rectangles over here, there's 5 rectangles, that area would be the surface area. That's what surface area is. Now, finding the surface area of this shape is going to be quite a bit more involved. There's 2 triangles on the sides that have, in this case, the same area. There's a triangle in the front. Here's a triangle in the front, a triangle in the front, and a triangle in the back that have the same area. And of course, the base can be found as area. You take those 5 things and add them up. But finding the areas of the triangles isn't super simple because we're not totally sure what this height is. We of course can find, like, we know the height of the whole pyramid. So the height of the whole pyramid would be drawn from the center to the top. The height of the whole pyramid is 30. That we can find. What's tougher is finding the height of, like, say, this green triangle right here. I'm going to save that for our next video, but I want you to think about how you could do that. Okay. So to recap, the volume of a prism is the base area times the height. The volume of a pyramid or a cone is base area times height times a third. Surface area is the combined area of all surfaces. And for any shape, if you need the formula for its volume or surface area or edge perimeter, just look it up. Just Google it and you'll find it. You do have to worry about if it's a right prism or not. Right? Like right prism again means it's going straight up. Whereas a slanted prism might be going like off to the side. So be cautious of that. But that's it for today. We've only got, I think, 2, maybe 3 more videos for the year. I think it's 2 more after this one. So we'll talk about spheres. and we'll talk more about surface area, and I think that covers it. Have a great day.